Alright guys, welcome back. Today we're gonna solve the day 7 of our daily leetcode challenge, and the question is string matching in an array. Now this question can be a medium and a hard if we try to do it using the algorithm which we are supposed to do, which is the KMT algorithm. However, since this is an easy question and the length of the words is already in the range of 100, so brute force method can also be applicable. String matching pattern is a proper algorithm called as the KMT algorithm. I'll show it to you right now. This is what we generally use, KMP, Kurth Morrison Pratt algorithm. KMP algorithm is what we use for questions like these. However, since this is a easy question, we will try to see the brute force approach for this one. Now let us understand what the question is asking us to do. So if you take a look at the first example, what they are trying us to say is you need to find all those words here, all those words in this list for which they are at least substring of at least one word. They could be substring of a lot of many other words, but if they are at least substring of at least one of the words, we have to return it. So this is what they say: return all string number that is substring of another word. So it could be any another word. In the case of mass, we see no such word here for which mass is a substring of. For as, we see mass is a word which is a substring of as. It could have been under another word here called as was. It would have been of that as well. But we just have to see if there's even any single word which satisfies the condition, and the condition is it a substring? Is it a substring of any other word in this list? So we have as in here as the answer. Hero is a substring for this word called superhero, so we have that as well. For superhero, we don't have any other word for which superhero is a word. Superhero is a substring of, so that's why we don't have that. Now if we come to the second example, we have leetcode ET and CODE. So we see again ET and CODE are answer because both these words are substring to this bigger word called leetcode. Now leetcode is not a substring for any other word. Now if you remember, every string is a substring of itself, but we'll be ignoring that, because if that would have been the case, every word would be an answer for itself. But since we are ignoring that case, that's why the question becomes if it's a substring of another word, not the word itself. So we have to keep that in mind as well. That is why the answer is ET and CODE for the second example. Now if we take the third example, we see there's not even a single word which is a substring of any other word. So blue is not a substring of any other words provided here. Green is not the substring of any other word provided here. Same with BU as well. Now if we try to understand what approach we can kind of take for this one, is that in order for a word to be a substring of another word, in this case at least, which the case that we are provided with, I can say that there is gonna be the word which is gonna be there itself, and there will be one more word which would be containing this word. As you see, as is getting contained in this word. Same way hero is there, and then hero is also getting contained in this word. There could be other words as well. Which could be containing hero, but we need just a single word for this to happen. So if you take a look, if I ask you for this result as what is the count of as that we are having in this list? So there's one count of as here and one kind of here in the middle. That's why it's the substring in the middle. Same with hero as well. One count here and the other count here. It could have been more examples as well, but in this case it's here. So what we can conclude is, for a word to be an answer, its count must be at least two. Only then it's going to satisfy. It cannot be one. If it's only one, then it's not the case. It has to be at least two or more. So if you see now what we are getting somewhere now. So basically what I'm trying to say, for each of the words, right, we have to basically somehow get a count how many times this particular kind of combination of letters MASS is appearing. This particular count of letters, arrangement of letters MASS, how many times is it appearing? Is it appearing more than one? Sadly not. It's just one mass. But for AS, it's appearing one here and one here. That's why it's a valid answer. Same with hero as well. It's appearing once here and once here. So that's why it's 2. So it's like is an answer. Superhero doesn't satisfy. Let's come to lead, the second example. If we take the example of ET, we see it's appearing once here and once here. So it could have appeared more times, but it doesn't matter. If it's one, at least two, it's there, then it's fine. So that's why ET is an answer. Same with code. It's appearing once here and once here. Now, how we can make this count? How can we check that the count stuff that we are doing right here? How can we do that? Now, what if I told you, like, we can use all these words here to form one mega kind of like a string which has all these strings, like all these words combined together. So what will that look like? So we initially we have this list, right? We have mass here, and then as, and then hero, and then superhero. So if we combine all that, it will look something like this: MASS, and then AS, and then hero, and then superhero. So again, now if you try to visualize it with me right here, this is what the final string will kind of look like: mass as superhero, right? And now we just need to go for each word, right? For each word that we have, let's say mass, how many times is it appearing? We have to do the count for it in this big string that we have found. How many times is it appearing? We see it's only appearing once. But for as, I'll use a different color for this one. For the word AS, it's appearing one here and one here. It is satisfying our condition. The condition is should appear at least two or more. Same thing with hero as well. Let's see how many times hero is appearing, right? So we see hero appearing once here, as it should be, and then again here. It could have been more as well, but it doesn't matter. It should be minimum two. If it's two, it's good enough for us. Then comes superhero. Superhero is appearing only once, right? So we cannot have that. So far the only words which are satisfying the condition are AS and hero. So this is how we are trying to like use the count to kind of solve this solution. The reason this is a big O of n square is because this counting part itself is gonna traverse through the whole string, which could be the sum, which would be actually be the length of the words multiplied with the average length. So it could be n dot m, where m is the average length of the word. So overall it's gonna, and then again we are doing a for loop, going word by word we are going, and for each word we are doing this n words. So overall, if you see, the time complexity will be n square for this one. However, since the solution set, the length of the words is somewhere between 100, so this solution is gonna work pretty fine. Now there's a one small thing that we need to check. If we code it up right now, we'll get an error. The reason is we are kind of missing out on one thing. Now to point it to you, let me mark the points where we actually did a join. So we did a join here, we did a join here, and we did a join here. Thankfully for us, in this example, there wasn't a word which was forming here, which was something which was already there. For example, mass, right? Mass actually appears just once. But what if there was a word which was kind of like a palindromic subsequence and continued by some other words, two different words, right? And then somehow in their combination we get a word which is already there. So this combination word technically does not exist. This combination word technically does not exist in the list, but we'll get the answer. It will be counted though. It won't be existing in the list, but it will be counted. So that will be a wrong answer, and this can happen on some test cases. So to avoid that, to avoid unnecessary words forming at the join itself, what we can do is we can separate these join by a space, so that there's no unnecessary words happening. We will still get the count and everything, but no unnecessary words will be getting counted, because if we do the spacing here, right, at all the joins, no unnecessary words will be forming and they won't disturb our count. Basically, that's what I'm trying to say. So this is something that you have to keep in mind in this algorithm. Other than that, this is how we are going to code it. exactly like that. So firstly we need a result which is going to result in array which is going to restore our result. Now I'm gonna declare a variable called as mega word, which will basically be combination of all the words in the words list joined by a space. This can be done using Python, and simply this and then words. So what this is doing is this is acting like a delimiter, basically the spacing that you're trying to provide. We are actually trying to provide a space. If I provide any other character here, right, let's say percentage, it's gonna add a percentage here. If I provide nothing, then it will just join them without any space. We don't want that. So that is why I'm just adding a space here. Now that we have this mega word, we'll simply do a run on this words for word and words. For each of these words, we simply just need to do a count in this mega word. If mega word dot count or this word is greater than 2, that's what we require, is greater than or equal to 2, right? In that case, this word is satisfying our condition. We'll add that to our resultant list, and then we are just gonna return this resultant list that we have. See, all the test cases are passing, and if we submit this, yeah, so this is, as you can see, is kind of beating almost it's beating most of the solution, and it's a good time it's like overall it's still a O(n) square, but it's running properly on the provided test cases. So this was the solution for today's question. Thanks for watching. Like and subscribe.